tuples are very similar to lists. The main difference with tuple data type is that they are immutable data structures. They are also container data types, so they can accommodate different data types inside them. To create a tuple, we can use the parentheses. To create empty tuple, we can write like this, or we can also use tuple function to create empty tuples. If we want to create a tuple of numbers, then we can create like this. If I check the data type of these numbers, then you can see it's of class tuple. We can create a tuple by using tuple function, and similar to list function, we can pass any other iterable data type into this tuple function. Tuple range 5, and it will create a tuple with 0 to 4 elements. If I pass a list of numbers into this tuple function, then also it will create a tuple with those elements. Tuples can also contain mixed data types like list. I can have integer, string, and a boolean data type like this. Tuples can also be nested. I can write a tuple with elements 1, true, and inside this tuple I can also have another tuple of string, orange and banana. If I print this tuple, then you can see that it prints this nested tuple. If I try to create a tuple with single element, then it's little bit different. Let's take an example. Here I'm trying to create a fruits tuple with only element apple. If I check the data type for this fruits variable, then it returns string. Even though I have used this parenthesis around this variable, it considers it as a string data type. In order to create a single element tuple, we have to specify comma at the end. Now if I check the data type, it correctly returns tuple. We don't even need to specify the parenthesis around the tuple. So if I write fruits equal apple, comma orange, then by default it will create a tuple with elements apple and orange. We can also index elements of a tuple. So if I have a numbers tuple with elements 1 to 5, and if I check numbers 0, then I get the first element from this numbers tuple. I can also use the negative indices like we use for list or string data types. Numbers -1, and I get back the last element of this tuple. For nested tuples, if we want to index an item, then we can use the same syntax. Let's recall our nested tuple. Here we have this nested tuple inside our outer tuple. Let's say I want to get this first element from the nested tuple. For that, I can write nested tuple and I index the second item, which will select this internal tuple, and in that internal tuple I want to get the first item, so it will be index position 0. And it correctly returns this string orange. I can use the len function to find the length of a tuple. Len numbers, and it returns 5. Tuples are immutable, so we cannot modify an individual element of a tuple. If I try to modify fourth item from this numbers tuple, then it throws type error. Tuple object does not support item assignment. This is similar to string data types. String is also an immutable data type, and likewise, tuple is also immutable. We can also perform slicing operations just like list. We can specify the start position, stop position, and the step we want to increment. Here in this numbers tuple, we have elements from 1 to 5. If I check numbers 2:4, then it gets the elements from index position 2 and 3. The item from the stop index is not included in the tuple. I can even omit specifying the stop index position, and it will by default select items up to the end of the tuple. If I check numbers 2:, then it will get all the numbers starting from index position 2 up to the end of the tuple. Similarly, if I omit the start position, then it will start from the 0 index position, numbers 4, and it will return the first 4 numbers from the numbers tuple. We can also get a reverse tuple if I use numbers : -1. Tuples are also iterable, so we can iterate through them just like we can do with list. I can write for loop like this. For number in numbers, print number. It will simply iterate through the numbers list, and it will assign each element to this number variable. And here we are simply printing that number. If we also want the index position, then we can use the built-in function enumerate. Let's say I have a tuple colors equals white, red, blue, and brown. Now if I also want the index position, then I can use for index, color in enumerate colors. This enumerate colors return a tuple with index and the element itself. So here we are unpacking that index and the color. Inside the for block, I can write print index and color. If I run this, it prints the index position and the respective color value. There are few functions available to work with tuple data types. If I have a tuple with elements 1, 2, and 3, and let's say I have other tuple with elements 4, 5, and 6. If I want to get a new tuple with all the elements of these two tuples, then in that case I can do something like this. Numbers plus others, and it returns a new tuple with elements 1 to 6. If I multiply a tuple by 5, then it returns a new tuple with 5 elements. Similarly, if I multiply this tuple by 3, you can see that it returns total of 9 elements, and these elements are repeated 3 times. If we want to find an element in a tuple, we can use the same index method. Let's create a new tuple of fruits with elements apple, orange, and banana. Now if I check fruits.index of banana, then it returns index position 2. If I try to look for an element that doesn't exist in this fruits tuple, then it throws value error. I could also use the in operator to find if an element exists inside a tuple. This operator simply returns true or false based on if the element exists in the tuple or not. Let's create a new tuple of all the odd elements from 1 to 10. Let's print this tuple. And we can see that it has elements 1, 3, 5, 7 and 9. Now if I check 3 in numbers, then it returns true. If I look for 4 in this numbers tuple, then it returns false. We can also use this in operator with our fruits tuple. Grapes in fruits, and it returns false. We can also find how many times a specific element occurs in a tuple by using count method. Let's create new numbers tuple with elements 1, 2, 3, 7, 4 and 3. In this tuple, I have this element 3 occurring 2 times in this tuple. If I check numbers.count of 3, it returns 2. We can completely delete a tuple by using del operator. If I write del numbers, this removes the tuple from the memory. Now if I try to look for this numbers tuple, it throws name error. Numbers is not defined. We can unpack a tuple into multiple variables. This provides very elegant syntax for variable assignment. Let's say I have a tuple with values 1, 2 and John. I can assign these 3 values to 3 different variables like this. If I check all of these variables, you can see that they have been assigned the respective values. While unpacking a tuple, we have to make sure that the number of elements in a tuple matches the number of variables on the left hand side. If they don't match, then it may throw an error. This unpacking feature can be used to return multiple values from a function. So if I define a function, sum product, and this function takes 2 numbers, num1 and num2. As an implementation, I can return 2 values. Return num1 plus num2 and num1 multiplied by num2. Here this return statement is simply returning a tuple containing the summation of 2 numbers and the multiplication of 2 numbers. Now I can use unpacking to assign these 2 values to 2 separate variables like this. If I check the value of these 2 numbers, then you can see that it has the value 6 and 8. If we want to swap 2 numbers, then tuples can provide an elegant solution for that. If I have a variable num1 with a value 1 and num2 with value 2. Now if I want to swap these 2 numbers, I can use num1, num2 equals num2, num1. Now if I check num1 and num2, you can see they have been swapped. In other programming languages, you would have probably needed a temporary variable in order to swap 2 numbers. But in Python, we can achieve that in a single line of code. That's the beauty of Python. In this video, we saw tuple data types. It's an immutable container data type.